quickly showcase some of the features and functionalities of my project Hermes Studio. It's a Hermes / React Native disassembler and decompiler and overall just analysis tool. We're going to open up the ultimateguitar.com mobile app for Android. I've already extracted the bundle here. Alright, so right now what's happening is the pattern analysis worker is running. That will match strings within the binary to known patterns that you can filter, deselect all. You can look up email addresses, potential file paths. There are some false positives. It's not perfect. It's just regular expressions. You can click the pattern to see exactly what they are. So I already know that there is a search endpoint here. So I'm just going to go ahead, click that, look up the cross references for it. I can see that it's being used in the fetch search function. Just go over here, we'll navigate to it. Alright, and yeah, this is type 2. Alright, we'll go ahead and decompile it real quick. Alright, the closure depth limit for this closure is set to 0. So we'll increase that. We'll increase it again. Alright, and we can see as a promise, it's passing in an object. So I guess I'll go ahead and just, call this payload. Alright, so it's, okay, and this is the context for this request. And this is just the closure. Alright, so we can see it's got status code handling, and it parses the response. I want to see where else this is actually being used. So I'm going to go ahead and click here, find cross-references to the fetch search function. Alright, and we can see here that this is actually a factory function for the Metro module, or the Metro bundler. Okay, so I guess we'll go ahead and check the decompilation output of this. Same thing, got a bunch of closures, massive control flow bug that I will fix. Closure depth limit. Alright, I'm just going to go ahead and search here. There we go. Alright, so tab search. We can see that the fetch search function is being exported in this module. So if we want to see which module it is, let's go back over here to the functions and see module ID 1747. So we can even filter this if we want, and then only look at modules within, or functions within this module. Alright, that's neat, and yeah, that's pretty much it. We have data viewers for different objects. If we do like console.trace, we can see the polyfills for the console interface, which Metro or React Native add. We can see where that's being instantiated. We can actually find the factory function for this as well. Actually, yeah, it's not a Metro module. This is actually a base polyfill, so there won't be a module for it. We decompile that, and look at the exact implementation. Pretty nice. We also have the ability for people to scale out. This essentially just mimics the browser functionality. Like the UI can be a little bit overwhelming and clunky when you're on just a laptop or other small form factor device, which is why I added that. You can also switch to light mode, which is terrible. I don't know why anyone would ever do this, but c'est la vie. We also have the ability to export strings as JSON, CSV, and text. Arrays, same kind of deal. Objects, we can export all of the bytecode with jump connections or as text, and then also export every single function decompiled, which is very, very useful. The filter on functions, strings, arrays, and objects all allow for regex, so you can just toggle that on and off. Here you can see the Hermes bytecode file header, as well as the footer hash, which is useful if you do any kind of recompilation. We like that. Yeah, if you're doing actual bytecode analysis, it's actually super useful to use the instruction info pane here. Not a lot of people know exactly what these instructions do, but here, I list out the opcode, all the operand bytes, and then some basic documentation with the real-world examples as it's used in the bytecode in the documentation. So, the registers are accurate, and if there's a string or any other normalized value or computed value, I display that as well. In the data viewer, obviously this will print out and allow you to filter arrays, objects, what have you. This is annoying. Yeah, so you can, well, let's go ahead and search dev dependencies. Oh, nothing in dev dependencies. Yeah, all right, there we go. You can see some internal packages, package.json here. Go ahead and take a look and see where that's being used. All right, this looks to be for a software mansion React Native reanimated repository. Go ahead and decompile that. Let's go ahead and take a look at it. That's not good. I'll fix that. And there we go. We have email addresses. Yeah, I'll fix this and put this in strings. Yay, bugs. Yeah, there's a lot of different functionality that's packed in here. If we want to filter by specific like key counts, like if we only want ones that have say 12 keys, we can do that. Obviously increase, decrease that. Arrays we can filter by specific types. So if I only want things that have true, I can obviously do that. Same with false. And these are like core JavaScript types within Hermes. Long strings, obviously available. We can also, compound them if we want. It's very, very nice. We can also filter by length as well. So we can say like, hey, we only want integer arrays that have a length of 30. With functions, we also have similar functionality. We can show only identified metro modules, or we can exclude all metro modules. So as you can see here with this particular application, we only have 77 functions that exist outside of the known and tagged metro modules. Let's see, in the global function, which is always the main entry point for React Native applications, and you can tell by the size. Obviously we have control flow labeling, but I also tag the metro modules as they're instantiated in the code based on a couple of different bytecode patterns. So if you want to see what is being instantiated and when, and then inspect the actual underlying factory function, you just click it. You can also navigate back. Another thing is you can find cross-references directly in here. Obviously, it'll just point back to itself. That's a factory function. That's the only place it's used. In the hex view, this is fairly nice. Create environment, load param. Oh yeah, two load params. Load const 0. If we look at that, create environment, load param, um, 3202, 3202, and then the actual absolute offset within the binary. So if you wanted to go modify a jump true to a jump false, then it's very, very simple to do. You just go to that address in your hex editor, and then modify the appropriate bytes as displayed. Um, and yeah, it's very, very easy to do. The only thing that you need to do for recompilation is to update this footer hash, which this is always going to be the last 20 bytes in your Hermes file, or your bundle. And it's just a SHA-1 of everything preceding it. And I do have a script available if anyone needs it. Yeah, I think, oh yeah, logs. Logging isn't great right now, working on it. And then the Hermes console. So I exposed the core Hermes object that powers this whole thing here. So you can check the, whoops, come on. Yeah, there we go. There's a little bit of a debounce issue there. Yeah, you can do Hermes function headers 0. This was hacked together. It's not the best. Let's copy this and then do flags. Do flags. Prohibit invoke is greater than 3. Just execute arbitrary JavaScript expressions based on the underlying data structure. Yeah, with any data table here, you can filter out specific values depending on whether or not it is, a reference, an array, whatever. So I can do like 759 here. That's cool. You can also filter the instructions. I'll find a good function for that. Let's see. Actually, we'll do is object. No, that's not a good one. What's a good function? Log, maybe. Actually, you know what? We'll create element. See if that's used. Oh, well. Either way, you can filter by the exact instruction and registers as it appears in this list. Yeah, it's I think it's a pretty good product so far. Let me know what you think.